The teak tree, scientifically called Tectona grandis, is one of the most valuable timber trees of the world. It grows naturally in about 9 million hectares of forest in India. But man-made plantations are more profitable and easier to manage for timber production, and therefore, teak is now mostly grown in plantations. What you see here is a teak plantation at Nilambur in Kerala. It was here at Nilambur that the technique of raising teak plantations was tried for the first time and perfected. That was in 1842, about a century and a half ago. From then onwards, teak planting has been a continuous activity of forest departments, and we now have over 1.5 million hectares of teak plantations in India. Kerala has about 70,000 hectares, of which about 10,000 are at Nilambur. We grow teak for its timber. It is one of the finest of constructional timbers in the world, with high durability and beautiful appearance when cut and polished. Teak is also famous for its excellent working quality, making it a carpenter's delight. Nature, however, doesn't make everything perfect for man. When grown in plantations, teak is damaged by a number of insects, of which 2 leaf feeders are the most important. One of them, scientifically called Hiblia pura, feeds on the young leaves of teak, leaving behind only the larger veins. The heavily damaged leaves dry up and fall off later. This insect is therefore called the Teak Defoliator. The other insect, scientifically called Tectona maceralis, earlier known as Pyrosta maceralis as well as Hepalia maceralis, feeds mostly on older leaves. It consumes all the green matter, leaving almost all the small veins intact. At times of heavy damage, only the skeleton of the leaf is left behind. This insect is therefore popularly known as the skeletonizer. Teak has other leaf feeders too, like this one, the Meloceros beetle, and others like the colorful chrysomelid beetles. But these insects seldom cause any serious damage. Of the 2 major pests, the Teak Defoliator is the most serious. It is a voracious feeder and a devastating pest. The adult insect is a small reddish-brown mottle moth. The female moth lays eggs on young tender leaves, attaching them close to the veins. Tiny larvae hatch out within 2 days. The young larva cuts out a small fold of leaf, bends it over and attaches it with silk, creating small purse-like pockets. The larva then feeds from within the leaf fold. When the fold is eaten up, the larva moves away and makes another fold, this time slightly bigger. And so on until the larva becomes full grown. Living within a fold is safer. Protection from enemies and from the weather, at least until the fold is eaten up. For all living organisms, the world is full of enemies. However, a delicate balance exists between each organism and its natural enemies, which ensures the survival of each species. Spiders are important predators of insects. Here, a spider catches hold of a Hiblia larva and sucks it dry. Different kinds of ants are other important groups of predators. One way to escape from a predator is to drop down on a silken thread, which most caterpillars do. They can then climb up on the same thread. Sometimes, the delicate balance between the Teak Defoliator populations and its natural enemies breaks down, particularly when food is plentiful. That is, when thousands of hectares of teak plantations put forth their new leaves prior to the arrival of the pre-monsoon showers. The stage is then set for the annual drama of Teak Defoliator outbreaks. The first episode of Outbreak may occur at one or two small patches. Usually, it follows the arrival of the pre-monsoon showers. These early erratic patches of defoliation may cover much less than a hectare and often go unnoticed. Larger outbreaks follow soon, usually by the end of May at Nilambur and sometimes earlier by April. In central parts of India, it happens only in July. There appears to be a link between the progress of pre-monsoon showers and the defoliator outbreaks, but the cause-effect relationships have not been fully elucidated. These outbreaks are very spectacular phenomena. They appear all of a sudden, and each leaf of each tree may harbor dozens of larvae. When the leaves are eaten up, the larvae hang down on silken threads and move to adjacent trees. At this time, you cannot walk through a plantation without gathering scores of larvae on your body and clothes. During the progress of outbreak, one can hear the sound of falling fecal pellets like that of drizzling rain. The floor is soon littered with black fecal pellets, small and big. Older larvae climb down on the tree trunks. The mature ones look out for a place to pupate on the ground, while those that are still hungry wander all over in search of green leaves. Within a few days, vast stretches of plantations, young and old, are stripped clean of their leaves. The lush green look of the plantation gives way to a dry, scorched appearance. Soon, the leaves fall off to the ground. Each passing breeze brings down more and more of dry leaf skeletons still clinging on to the trees. The mature larvae make cocoons and pupate on the ground, often in clusters attached to the undersurface of old fallen leaves. From these cocoons, moths emerge in about a week, and the cycle starts all over again. Large aggregations of moths have often been noticed in some places, and the evidence indicates that the moths get together and undertake mass movements to start the next outbreak episode elsewhere. Repeated outbreaks may occur in the same plantation, apparently caused by moth populations immigrating from other places. What is the impact of these repeated defoliations on the growth of the tree? Starting from the 1920s, there have been much speculation over this question. Most recognized that there was some loss of wood increment. Some put it at 6%, some at 13%, and some at 66% of the potential increment. But all these estimates were based on a mixture of guesswork and data. Only the proportion varied. At last, in the 1980s, the Kerala Forest Research Institute carried out a 5-year study at Nilambur to answer this long-standing question. They found that in 4 to 8-year-old teak plantations at Nilambur, the mean height increment of protected trees increased from 1.97 meters to 3.95 meters, a 101% increase. Similarly, the girth increment increased from 12.06 centimeters to 18.39 centimeters, a 52% increase. In terms of wood volume, the increment put forth by the protected trees was 80% higher than that of unprotected trees. What is more interesting, the KFRI study showed that the skeletonizer, which feeds on older foliage during the later part of the season, had no significant impact on growth. On a per hectare basis, the unprotected trees gained 3.7 cubic meters of wood per year, while the protected trees gained 6.7 cubic meters of wood per year, a difference of 3 cubic meters of wood per hectare per year, a very substantial gain indeed. Having established the need for control, the attention of KFRI researchers have now turned to devising appropriate methods of control. Aerial spraying of insecticides has been tried in the past, but this entails very high environmental cost. It must therefore be ruled out. The emphasis is now focused on biological control methods. Some biological control does take place in plantations naturally, but they are effective only when the pest population is small, and not all of them can be used to our advantage. For example, during outbreaks, birds are a common sight in plantations. 48 species of birds have been found to feed on this insect at Nilambur. Large flocks of crows can often be seen feasting on Teak Defoliator, but the number of larvae are so large, running to millions, that many larvae are able to escape from being eaten. Moreover, by the time the larvae are big enough to attract the crows, the damage is already done. Our hopes are now centered on a naturally occurring nuclear polyhedrosis virus, NPV for short. NPVs are very specific microorganisms affecting particular species of insects and are safe for human beings and other animals. Supported by funds from the Department of Biotechnology, Government of India, the KFRI is developing the technology for practical use of the NPV to control the Teak Defoliator. Preliminary field trials have given promising results. In 1993, an experimental plot of 100 trees at Nilambur was continuously protected by application of NPV. An artificial diet has been developed to rear the insect in the laboratory without teak leaves. A solar-powered light trap was developed and established at Nilambur to monitor moth populations. An automatic weather station has also been established. Using these data, attempts are now being made to develop outbreak prediction models. This is necessary to time the application of control measures accurately. With effective biocontrol agents and suitable application technologies, the dream of harvesting fully grown teak in 30 to 35 years instead of 60 years is now within the realm of reality. A word of caution is however due. In our eagerness to produce more wood, we should not resort to the use of insecticidal chemicals in the forest ecosystem, as it can be counterproductive. In addition to sacrificing the quality of our environment, indiscriminate use of insecticides can alter the pest system and aggravate pest incidents. Let us use science, but use it judiciously.